everyone. This is Kiran. Let us today discuss about refraction of light at curved surfaces from 10th class, chapter number 4. Right. In this topic, we have to learn about image formation and derivation of curved surface formula. Derivation of curved surface formula. Right. In this topic, we have to know about the light rays which passes from rarer to denser and denser to rarer. We already know in the previous classes about the refraction of light at plane surfaces. In that context, how we discuss here curved surfaces means this is an example of a curved surface. For example, this seems to be a sphere, right? This seems to be a sphere. If we cut the sphere into two parts, when we cut the sphere into two parts, then the surface is said to be as a convex surface. Convex surface. How can we say this is a convex surface? When light rays are passing in this direction, when light rays falls on the surface in this direction, then the surface is said to be as a convex surface. When you see here, one more surface is there. This is another surface. When light rays are traveling in this direction, this seems to be a cave. So this surface is said to be as a concave surface. Concave surface. In this derivation, image formation and derivation of curved surface formula, we have to know about the formula about n2 by v minus m1 by u is equal to n2 minus m1 by r. This is the derivation formula for curved surfaces. n2 by v minus m1 is equal to n2 minus m1 by r, where n2 and m1 are refractive indices of two media. For example, n1 is taken as a refractive index of air media and n2 is taken as refractive index of another media. U means the object distance from the pole. V be the image distance from the pole. All the distances should be measured from the pole. For example, this is the surface which is filled with water. This is filled with water, and this medium is said to be as this is filled with what? Water. This is filled with water, and this medium is said to be as denser. And this is a air medium. This one is said to be as a rarer medium. Okay, right. The midpoint of the surface. The midpoint of the surface is said to be as a pole. The midpoint of the surface. The midpoint of the surface is known as pole. It is denoted with by letter P. B is indicated with the letter P. So this is a pole. When you see here, this one seems to be a sphere, right? This one seems to be a sphere which is having a center here. If we consider this as the whole sphere, this is having the center here. This one is said to be as a C, center of curvature. This one is said to be as a C, is said to be as a center of curvature. C represents the center of curvature. Center of curvature. The line that joins the points P and C here. The line which joins the points of pole and the center of curvature, that line is said to be as a principal axis. What is this? Principal axis. The line that joins the points of P and C means P means pole and C means the center of curvature. The line which joins these points are said to be as principal axis. Okay. Then P be the pole and C be the center of curvature. The surface. This is the surface, and this is the principal axis which joins the points of P be the pole and C be the center of curvature. When you see here, a point object is taken here, a point object O is taken here, and the light rays which passes through the principal axis does not deviate. This already we know about this. The light ray from an object which passes through the principal axis does not deviate. Principal axis ఉన్న వెళ్ళేటటువంటి లైట్ రే అనేది deviate అవడం జరగదు. Next, when the light ray passes in this direction, light ray passes in this direction, and this surface is what? Convex surface. This is what? Convex surface. Right. When light ray traveling in this direction, this is having an angle alpha here. What is the angle here? The angle made with the principal axis. The object passing the ray from an object passing in this direction and making an angle alpha with its principal axis. Principal axis toti alpha and angle make చేస్తున్నప్పుడు చూడండి ఒకసారి. This one is said to be as the center of curvature. From this particular point, we have to draw a normal like this. This one is said to be as the normal. From any point, we have to draw normal. From any point on the surface of the curved surface, from this curved surface, take a point like this A. A be the point, and draw a perpendicular line to C. And next, the ray. This one is said to be as incident ray. Ray. In previous classes, we already know about plane surfaces, refraction of plane surfaces. We already know about the topic. Then light ray passes from rarer to denser, and light ray passes from rarer to denser. The refracted light ray bends towards its normal, towards the normal. This one is here what? This is a curved surface. Here, this one is a curved surface. A light ray strikes at point A and deviates with an angle. For example, this is making an angle here. This one makes an angle gamma, and this makes an angle beta. Let us take another point which is perpendicular. This one is a perpendicular line N. Okay, from A I have to draw an perpendicular line AN with a perpendicular line, and OA B. Let us consider this point as a B. Then what happened? See here, OAB is a triangle, right? OAB is a triangle, and it makes an angle. This one is a refracted ray. This one is a refracted. This one is refracted ray and makes an angle gamma with its principal axis. The refracted ray makes an angle gamma with its principal axis. And second one, I have drawn a perpendicular from C to point A. This one is seems to be a sphere. On a particular point on the sphere, we have to draw so many normals from point C, center of curvature. From center of curvature, we have to draw so many number of perpendicular lines. So I have drawn here CA with a perpendicular line, and AM with a perpendicular here. AM with a perpendicular straight line. Here makes an angle beta. The normal makes an angle with its principal axis is beta. Let us assuming that these values are assuming for the derivation of N2 by V minus N1 by E is equal to N2 minus N1 by R. To derive this formula, we have to assume these values like this. Then after that, from a triangle, see here what we are observing. When we see here, this is a ray, incident ray, and this is a refracted ray. From plane surfaces, we have know about a light ray incident on a surface. It gets refracted. Then it travels from air medium. This one is N1, this one is N2. from air medium to denser medium. This one is second surface, strikes at the surface and having a N2 with the refractive index. For example, the light ray travels from air to the surface. The light ray travels from air to the surface. So M1 with the refractive index of air. M1 with the refractive index of air. And N2 with the refractive index of N2 with the refractive index of second surface. Air surface and second one is taken as the second surface. So N2 with the refractive index of second surface, N1 with the refractive index of air surface. We know the value of our air is N1 is equal to taken as air of refractive index of 1.0003. This is considered as simply 1. This is considered simply as a 1. So how to derive this formula? See. Let us see here. From the figure, this is for example image is formed here because of the first refracted light ray which does not deviate. The first light ray passes through along the principal axis and it goes through point I. For example, here we are considering it's not B, it is taken as image because of at B point image will be formed. Image will be formed. So I am considering this value as I. Image. I be the image of an object. Taken O be the point object. O be the point object. O be the point object. The light ray passes through. The light ray passes through the principal axis. Principal axis does not deviate. Does not deviate. We already know this. And in the second case, the incident ray strikes at the incident ray strikes the second surface, the surface at A position and refracted and meets the refracted ray on principal axis at a point I. Here image is formed at a I position, so I am considering it as a I. From triangle, okay, we already know that what is meant by angle of incidence. Angle of incidence. The incident light ray which makes angle with its normal. The incident light ray which makes an angle with its normal is said to be as an angle of incidence. This is taken as theta 1. This is taken as a theta 1. And the refracted light ray which makes angle with its normal is said to be as a theta 2. This one is taken as a theta 2. Okay. Theta 1, theta 2 are theta 1 with the angle of incidence and theta 2 with the angle of refraction. Angle of what here? Refraction. Okay. Angle of incidence and angle of refraction. Because AC is a perpendicular line or normal. AC is a normal line. To this normal, incident ray making an angle theta 1. So this one is said to be as angle of incidence. And theta 2 be the angle of refraction. This is the refracted light ray, which makes angle with its normal line having a theta 2 angle. So this one is said to be as angle of refraction. Okay, right. From triangle, in triangle, okay, triangle, from triangle AOC. AOC. Triangle AOC. See here, theta 1, alpha and beta. What relation did we observe from these values? Theta 1 is said to be as the exterior angle. Exterior angle. Next one, alpha and beta are interior angles of a triangle. Okay, alpha and beta are interior angles of a triangle. So we have to write theta 1. The exterior angle of a triangle is equal to the sum of interior angles of the triangle, alpha plus beta. These two are the interior angles of a triangle. Theta 1 is equal to alpha plus beta. Alpha plus beta. This is taken as a 1. This is taken as value 1. Next, we have to take another triangle. From triangle ACI. From the triangle we have to know about. See here, ACI. Beta is exterior angle for this triangle. Beta is the exterior angle of this triangle. According to this, beta is equal to theta 2 plus gamma. From this we have to reduce theta 2 is equal to beta minus gamma. This is equation number 2. This is equation number 2. This is the Snell's law formula. N1 sin I is equal to N2 sin R. This is the Snell's law formula. What is the N1? What is the N1 N2 values here? Substituting these two values in this equation, theta 1 and theta 2. Here, theta 1 is taken as an angle of incidence, right? I is considering as I is equal to theta 1. I is equal to what? Theta 1. And R is equal to taken as a theta 2, angle of refraction and angle of incidence. We have to write these values in here. N1 sin theta 1 is equal to N2 sin theta 2. N1 sin theta 1 is equal to N2 sin theta 2. Substituting these values in equation, above equation. For example, this is taken as 3. From 1, 2 and 3 equation, N1 sin theta 1. What is the value of theta 1? Alpha plus beta is equal to N2 sin. What is theta 2 value? Beta minus gamma. Okay. Do you understood? Okay. Another N1 into sin alpha plus beta equal to N2 into sin beta minus gamma. When you see here, the light rays are traveling. So many of our light rays are traveling in this direction. For example, you have to consider like this. So many of light rays are traveling in this direction, and it gets refracted at different positions. For example, here these are making at one particular point. These rays all are coming towards the principal axis, right? The light rays which are incident on this surface are coming towards the principal axis. So these rays all are coming towards the principal axis. Then what will we observe? The rays which are coming towards the principal axis, those are said to be as paraxial rays. What are those rays? Paraxial rays. The rays which are coming towards the principal axis, those rays are said to be as paraxial rays. Okay. For these paraxial rays, at one particular position, the light ray does not deviate, and the angle between the angle of incidence value is always reducing. So when you see here, for the least value of sin of alpha plus beta, it becomes alpha plus beta. Alpha plus beta. For example, it becomes 0. What? Alpha plus beta becomes alpha plus beta is equal to 0. The angle made by alpha and beta is 0. Alpha plus beta is 0. Sin 0. What is the value of sin 0? 0. So we have to take sin alpha plus beta is equal to what? Alpha plus beta. Here we are considering 0, so in place of alpha plus beta we have to write 0. Like that, n1 into alpha plus beta is equal to n2 beta gamma. Okay. From this equation, n1 alpha plus n1 beta is equal to n2 beta minus n2 gamma. Okay, do you understood? Number, for example, this is considered as a 4. Equation number what? 4. Next, since all angles are small, all the angles are small because of these paraxial rays all are coming towards the principal axis, and the angles becomes small, very small. So, for example, when we are considering here tan alpha, what is the value of tan alpha here? From triangle ANO, from triangle ANO, what is the value of tan alpha? What is the value of tan alpha? Opposite side by what? AM by OM. Opposite side by adjacent side, right? Tan alpha is equal to AM by OM. And from triangle ANC, from triangle ANC, from triangle ANC, tan beta. What is the value for tan beta here? Opposite side AM by adjacent side. What is adjacent side here? CM or MC. Okay, MC or CM, whatever may be. Tan beta is taken as AM by NC. From triangle ANI, triangle ANI, from the triangle tan gamma is equal to opposite side AM by adjacent side what? NI. The angle between these rays are very less or small angle because of these all rays are coming towards the principal axis, and the angle becomes very small. For those values, tan alpha becomes AM by OL, tan beta is equal to AM by NC, tan gamma becomes AM by MI. For these values, when you see here, these rays are coming towards the principal axis, and the perpendicular AM becomes AP. AM coincides with the AP. AM coincides with the AP, right? AM is coincide with the AP. So in place of AM we have to write what we write? AN means AP by OP. OP because of OP. Here we have to measure, for example, here OB the point object, OB the point object. We have to measure all the distances from the pole. Sign conversion rules. These are very important for this topic. First one, all the distances to be measured from the pole P. All the distances are to be measured from the pole P. And second point, for example, the light rays are traveling opposite to the direction of. The light rays are traveling in one direction. The light rays traveling opposite to the direction of an object distance. The light rays traveling opposite to the direction of an object. For example, see here, object is in this direction. We have to measure all the distances from here. P to pole. P means pole from object. So we have to calculate all the distances from pole. In the topic, the light rays traveling opposite to the direction of an object. Then it is taken as then the sign convention is sign convention negative. Sign convention is taken as a negative. If the light rays are traveling, for example, see here, we have to measure object distance in this from pole to an object. The light rays are traveling opposite to the direction. Then what is the object distance? Object distance is taken as a object distance is is taken as negative. Okay. For example, in this diagram, OP or PO. OP be the object distance. Object distance is taken as is indicated with the letter U. Object distance is indicated with the letter U, and we have to measure from pole to an object. The light rays are traveling opposite to the direction of an object. Object direction के light rays are traveling opposite to the direction of an object. So object distance is taken as a negative here. OP is taken as a minus U. Okay. In this values, tan alpha is by NO. This value becomes alpha, and this value becomes beta. This value becomes gamma. Because of for the smallest value of angle, for example, tan 0. What is the value of tan 0? 0. The angle becomes very small. The angle becomes very small. So tan alpha is equal to alpha. It becomes alpha. Tan beta is equal to beta. Tan gamma is equal to gamma. In this n coincides with the point what P. So an coincides with the AP. An coincides with the AP. In this derivation, an becomes what? AP by alpha is equal to AP by OM means OP. OM means what? OP. Next. Ni, okay, right. Here see here, Ni, No, Nc are coincides with which point here? Are coincides with the n. In place of n, we have to write what? Pi, Po, and Pc. Why we are writing like this? N coincides with the point P. So Ni becomes Pi. NO becomes PO, NC becomes a PC. Okay. Here we have to write in place of Ni here. NC means PC. Okay. This value is taken as AN. Okay. AN by ON means OP. Tan beta. And beta is equal to, beta value is equal to, AN means what? AN by NC. In place of NC we have to write PC. And gamma. Gamma value is equal to AN by Ni. Gamma is AN by Ni. In place of AN we have to write AN by Ni means Pi. Okay. This is taken as minus U. OP is taken as object distance. OP is taken as an object distance. We have to measure all the object distance from its pole. From its pole. This is pole and this is object. Object distance is measured with the small letter U. And the image distance from Pi. This is the image is formed at a point I. The point sized image, the point sized object is taken at O, and image is formed at I because of the light ray which is traveling through its principal axis does not deviate, and the second light ray passes through its surface and gets refracted at a point I. Gets refracted at a point I. These two rays are meeting at one particular point here. The image will be formed. The image will be formed here. So from P to I, what is the distance here? V. Image distance is indicated with the letter V. Image distance is measured with the letter V here. From these values, from equation 4, we already got that N1 alpha plus N1 beta is equal to N2 beta minus N2 gamma. Okay. What will happen here? N1 and 2. Okay, right. N1 alpha plus N2 gamma is equal to N2 beta minus N1 beta. From this we have to common beta here. Beta value common. Then N2 minus N1 is equal to N1 alpha plus N2 gamma. Okay. Beta is equal to n2 minus n1 into n1 alpha plus n2 gamma. We know the values here. What is the value of alpha? An by OP. An by OP. By substituting these values in this equation, we got what? Alpha. In place of alpha, we have to write beta. What is the beta value here? An by PC. N2 beta minus n1 beta is equal to n1 alpha plus n2 gamma. We have to write beta value n2 minus n1 into beta value means beta is an by pc is equal to an by pc is equal to n1 into alpha. What is the value of alpha here? Tan alpha becomes alpha. Tan alpha is equal to an by op. An by op plus n2 into gamma. What is the value of gamma here? an by pi. An by pi. By substituting these values, we know the center of curvature here. From pole to center of the sphere is said to be as the distance between pole to center of the sphere is said to be as radius of curvature. Radius of curvature. The distance from the pole to the center of the sphere. The center of the sphere is known as center of curvature. Sorry, radius of curvature. This is said to be as the radius of curvature. This is said to be as radius of curvature. It is indicated with a capital R. From these values, n2 minus n1 into what is the value of an here? An is an by pc. What is the value of pc? Already told that pc is equal to capital R. Pc is equal to what? Capital R. This is in the direction of light ray, so it is taken as a positive. An by R is equal to what? Next, n1 into an by OP. What is the OP distance? Minus q. It is taken as minus q plus n2 into an by pi. What is the distance of v? Okay, n2 minus n1 into an by r is equal to an. We have to common an here. n1 by minus u plus n2 by v. What is the next? By two sides an get cancelled. An get cancelled. n2 minus n1 by r is equal to what? n2 by v minus n1 by u. This is the formula or derivation for the image formation and the derivation of a curved surface formula. n2 minus n1 by r is equal to n2 by v minus n1 by u. This is the formula or derivation for this image formation and derivation of a curved surface formula. Okay, I hope you all understood. For refraction of light at plane surfaces, we already know that for refraction of light at plane surfaces, this R value becomes very high. R value becomes very high. For example, I am taking 2 by value becomes infinity. What is the value here? It is approximate. Its value is equal to 0. The refractive index of on plane surfaces R, capital R value becomes high, very high. Plane surfaces, the refractive index, the radius of curvature becomes more. For that, n2 minus n1 by r value increases. If r value increases, n2 by n2 minus n1 by r, the total term becomes 0. The total term becomes 0 is equal to n2 by v minus n1 by u. From this, n2 by v is equal to n1 by u. This is the formula for refractive index of refraction of a plane surface formula. This is the image formation. Of plane surfaces. Image formation for plane surfaces, and this is a formula for curved surfaces formula. Curved surfaces which is having a center of curvature, and the distance from a pole to its center of curvature is said to be as the radius of curvature. R be the radius of curvature. N2 minus N1 by R is equal to N2 by V minus N1 by U. This is the derivation. Okay, I hope you are understood about the concept. Thank you.